Good evening, dear students. Today, what we'll do, today we will make some practice on hyperbola. So, we recently concluded the theoretical discussion on hyperbola. So, I will give one by one question and I will also solve it. So, what you need to do, dear students, is that you also solve along with me and you see the way things are progressing. The moment you get some confusion or some doubt, you can always let me know. The purpose of doing this thing is that once you start solving along with me, things will be clear. And as I suggested earlier also, that you can keep that notes, the class notes, whatever we have discussed earlier, along beside you, so that you can look into those, because we are practicing now. So that you need to look into the relevant formulas, because you may not able to remember all these formulas now, as we just concluded theoretical discussion on hyperbola. So the first question I'm going to give you now, and before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly? Can someone please confirm, please?
Yes.
Okay, great. Thank you very much. So this is the first question. The question here is that, if the length of the lattice rectum and length of transverse axis of a hyperbola are 4 root 3 and 2 root 3 respectively, then what is the equation of the hyperbola? That is actually the question. Now, the length of the lattice rectum is 4 root 3. So as the length of the lattice rectum is 4 root 3, so what we can say, that if you look into that corresponding study material, dear students, that 2b square by a, that is the length of the lattice rectum, that is equal to 4 root 3. So 2b square a by a is equal to 4 root 3. That is one information you got. And dear students, what is the length of the transverse axis? Length of the transverse axis is 2a, okay, and that is equal to 2 root 3. So 2a is equal to 2 root 3. And dear students, whenever I write this thing, so we assume that the equation of the hyperbola is x square by a square minus y square by b square equal to 1. This is the equation of the hyperbola we have assumed. And based on that assumption, the length of the lattice rectum is 2b square by a, and that is equal to 4 root 3. And the length of the transverse axis is 2 root 3. That means 2a equal to 2 root 3. Now, if you 2a equal to 2 root 3, so that implies that a is equal to root 3. So dear students, the moment, there is a technique, the moment you got a is equal to root 3, that means a square equal to 3. So the moment it is a square equal to 3, if you just look into the 5 options, you see that option C and option D are nullified. They cannot happen. Option C cannot happen. Option D cannot happen. Okay. Now let's proceed further. So we get a is equal to root 3. So as we get a is equal to root 3, so we can write it here. So then from here what we get, 2b square is equal to 4 root 3 into a. That means 4 into root 3 into a, we got root 3. So that implies what we get is that, dear students, that b square is equal to, we get 3 into 2, that is 6. B square equal to 6 we got. And as a is equal to root 3, so from here what we get a square is equal to 3. Now if we apply these two values, that a square equal to 3 and b square equal to 6, we get the correct option as option E, that is x square by 3 minus y square by 6 equal to 1 is the equation of the hyperbola. I hope it is absolutely clear, dear students, and I can proceed to the next question. Any doubt, any smallest doubt, never hesitate to let me know. Any smallest doubt, never hesitate to let me know. Okay, these are very straightforward questions, basic level questions. Now let's proceed to the next question, dear students. And next question I'm going to place in front of you in another few seconds. So, dear students, here is the second question, and question here says that if the eccentricity of the hyperbola x square by a square minus y square by b square equal to 1 is 5 by 4 and 2x plus 3y minus 6 equal to 0 is a focal chord of the hyperbola, then the length of the transverse axis is equal to what? So now, dear students, the length of the transverse axis means what? It is 2a. Okay, all we need to find the value of 2a. Okay, according to the question, what is given? It has been given that eccentricity, that E is equal to 5 by 4, that is given. Correct? Now, we know what is the foci of a hyperbola. That foci of hyperbola is foci of a hyperbola is plus minus AE comma 0. Plus minus AE comma 0. That means if we take it, the value of E as 5 by 4, so we can get that is equal to plus minus, 5a by 4, 5a by 4, comma 0. Correct? So now the focal chord is what? The equation of the focal chord is, according to the question, equation of the focal chord is 2x plus 3y minus 6 equal to 0. Focal chord means what, dear students? Focal chord means it passes through the focus. That means the coordinates of the focus, that is plus minus 5a by 4, comma 0, must satisfy this equation 2x plus 3y minus 6 equal to 0. Correct? So from here what we get, dear students? 2 into plus minus, so we can write 2 into plus minus 5a by 4, correct? Plus 3 into y is 0, minus 6 is equal to 0. I hope it is absolutely clear. Now from here what we get, dear students, is that plus minus 5a by 2. So from here what we get is that plus minus 5a by 2 is equal to 6, and eventually we get the value of a is equal to plus minus 12 by 5. Correct? Now length of the transverse axis is 2a, and we take that positive value because it is the length. So we take the value of a is equal to 12 by 5. So what we get is that length of transverse axis, is equal to 2a, that is equal to 2 into 12 by 5. Okay, we are considering that we take a is equal to 12 by 5. Okay. Okay, so that is equal to, we get 24 by 5. And as you see, out of this, all these options, that options what we get is the D is the correct option. I hope it is very well understood, dear students. Just have a quick look. A very fundamental question. It's not, a very complex question, what I can say. So when we took the value of A, you can write the best logic is that by taking A is equal to 12 by 5. Okay, dear students. I hope things are clear and you can move to the next question. And the next question will be in front of you in another few seconds. Okay. Here you see question number 3, the third question. What it says that the length of the transverse axis of a hyperbola is 2 cos alpha. The foci of the hyperbola are the same as that of the ellipse. 9x square plus 16y square is equal to 144. And we need to find the equation of the hyperbola. So as we need to find the equation of the hyperbola, let's see how we can proceed further. Okay, dear students. So now, if you look into this question, that what is very important to minutely look into the the information what has been given. What has been asked, that to clear. That is, you need to find the equation of the hyperbola. But what is important is that what are the information given? Okay, so equation of the hyperbola. So let us assume the equation of the hyperbola be x square by a1 square plus y minus y square by b1 square equal to 1. So let us assume that equation of the hyperbola be x square by a1 square minus y square by b1 square is equal to 1. Okay. Now, according to the question, that the length of the transverse axis of this hyperbola is 2 cos alpha. And what we know, dear students, the length of the transverse axis of this hyperbola is 2a1. So what we get, dear students, that 2a1 is equal to 2 cos alpha. From here, what we get, dear students? From here, we get a1 is equal to cos alpha. So this one information we got. Now, according to the question, the eccentricity of this hyperbola is same as the eccentricity of the ellipse. And what is the equation of the ellipse? Equation of the ellipse is that, let me write it here, 9x square plus 16y square is equal to 144. Let us write this equation of this ellipse in the standard form. Then what we get? X square by 16 plus y square by 9 is equal to 1. And if you recall, the formula for eccentricity of an ellipse is that E is equal to square root of 1 minus b square by a square. So that we are going to find it out. So from here, what we get, the value of E is equal to square root of 1 minus b square by a square. And if we find that value, dear students, so that is equal to square root of 1 minus 9 by 16. And eventually we get the value of E is equal to, square root of 7 by 4. So as we get the value of this, E, and that E is same as that of that hyperbola. Okay, now according to the question, okay, the foci of the hyperbola, I'm sorry, there is a small mistake I made, that the foci of the hyperbola is same as that of the ellipse. It is not the eccentricity. Eccentricity cannot be equal. For ellipse, the eccentricity is less than 1, and for hyperbola, the eccentricity is greater than 1. So that statement was not correct. But what I wanted to mean is that the foci of the hyperbola is that of that same as that of the ellipse. So what is the foci of that ellipse? Foci of that ellipse is, plus minus AE, correct? So what we get, dear students, the foci of the hyperbola, if we, we can write it here, is that foci of hyperbola, and if we assume this as E1, that is equal to foci of ellipse, and that is nothing but E. So what is the foci of hyperbola? That is nothing but plus minus A1 U1, A1 U1, and that is equal to plus minus A into E. So what we can write is that, plus minus we can get cancelled. What is A1? A1 is cos alpha. So from here what we get is that cos alpha into E1 is equal to A into E. What is the value of A? The value of A, what we get is that, 4, because that A is from that ellipse. That is 4. And what is the eccentricity we got? Square root of 7 by 4. So from here, what we get, the value of, cos alpha into E1 is equal to square root of 7. So that implies, cos alpha into U1 is equal to square root of 7. Now, dear students, that, what is the, value of, eccentricity of a hyperbola? For a hyperbola like x1, x square by a1 square minus y square by b1 square equal to 1, if its eccentricity is u1 of that hyperbola, then u1 should be equal to square root of 1 plus b1 square by a1 square. Correct? So from here, what we can write, dear students? So let's make a little bit more derivation. So from here, what we get is that this implies cos alpha into u1. u1 is square root of 1 plus, b1 square divided by a1 square. a1 square, a1 is already, we got it as cos alpha. So that is equal to cos square alpha. And that is equal to square root of 7. That is equal to square root of 7. So cos square alpha plus b1 is equal to cos square alpha plus b1 square is equal to 7. Correct? Because if you simplify cos alpha will get cancelled. So what we get is that cos square alpha plus b1 square is equal to 7. And eventually, we get the value of b1 square is equal to 7 minus cos square alpha. 7 minus cos square alpha. So that is the value of b1 square, dear students. And we already found the value of a1, and it is here, that is, cos alpha. Now, if we apply both these values of, a1 and b1 in that in the equation of that hyperbola. So what is the equation of the hyperbola? Let me circulate. This is the equation of the hyperbola. Correct? That's what our assumption was. So what is the equation of the hyperbola? We are going to get it here. That we are going to get it as x square by a1 square. From where that a1 square is coming? From here a1 square is coming. That is actually cos square alpha. Okay, minus y square by, what is, from where the b1 square is coming? from here, and that we get is that 7 minus cos square alpha. Okay, and that is equal to 1. And if you look into all these options, dear students, this is, let me first write it down. This is the required equation of the hyperbola what we got. And if you just look into all these 5 options, we see that it is actually mapped with the first option, and eventually we get the correct option as option A. I hope, dear students, it is absolutely clear. Now, before proceeding for the next question, let me reiterate one small mistake I made while describing the solution. That I said that foci, that eccentricity of that ellipse and that hyperbola is same. It cannot be. That was wrong. What is correct is that, as mentioned in the question, the foci of the hyperbola is same as that of the given equation of the ellipse. That means that coordinates of the foci of the hyperbola, whose equations we just found out, is same as the coordinates of the foci of the ellipse. That is 9x square plus 12 is 9x square plus 16y square is equal to 144. Okay, so I hope things are absolutely clear, and I can move to the next question, dear students. Okay, dear students, so next question I'm going to place in front of you in another few seconds. Okay. And you see, it is a little different type of questions, though, and I hope you will, like this question, and we'll solve it together. So the question here is, dear students, is that the number of points A comma B, the number of points A comma B, okay, where A and B are positive integers, lying on the hyperbola x square minus y square is equal to 512 is, what means how many such, points possible. And that is what we are going to discuss now. Okay, let's see that how we can approach this problem. So if you look into the equation of the hyperbola, from here, what we can say, dear students, is that x square minus y square is equal to 512. So what is that? X square minus y square is equal to 512. Now, dear students, A and B are the points on that hyperbola, lying on that hyperbola. So x equal to A, we can write, x equal to A and y equal to B. And we will get something like this. This implies A square minus B square is equal to 512. Now, let's look into it that, in how many ways we can find the values of A and B. And, from here, the question doesn't belong to exactly on hyperbola. The question belongs to, that how we can, it belongs to the number system basically. And you see that how I am solving it. So A square minus B square, actually we can write is that, that is equal to A plus B into A minus B. And 512 we can write, dear students, it is equal to 2 to the power 9. Now, in how many ways we can write that A plus B and A minus B to be, so that their product is 2 to the power 9. So the different, values of these products, what we can get the tuple actually, that to satisfy this one, what we are going to get, dear students, is something like this, is that, A plus B comma A minus B. If we look into it, so it will be something like this, 2 to the power 8 comma 2, 2 to the power 7, 2 to the power 7 comma 2 square, 2 to the power 6 comma 2 to the power 3, 2 to the power 6 comma 2 to the power 3, 2 to the power 5 comma 2 to the power 4. Okay, so these are the different ordered pairs we can get. So what we get is that number of ordered pairs is 4, and eventually we get the correct option as option B. Okay, so these are the number of points, by A and B, so that we can that is lie on that hyperbola x square minus y square is equal to 5, 1, 2. So I hope it is clear, dear students, and we can move to the next question. And next question will be available to you in another few seconds from now. Okay, let's look into it. So here is a question, dear students, that is question number 5. Okay, the question is that a hyperbola passing through a focus of the ellipse x square by 169 plus y square by 25 equal to 1. Its transverse and conjugate axes coincide respectively with the major and minor axis of the ellipse. The product of eccentricities is 1. Then what is the equation of the hyperbola? Very good question. Why it is a good question? Because here with this question you need to apply your knowledge in ellipse and hyperbola together to solve this question. Okay, here it is. Let us assume the equation of the hyperbola be something like this. That let the equation of the hyperbola be x square by a square minus y square by b square is equal to 1. This is the equation of the hyperbola. Okay. Now, and this is what you need to find, means very precisely to be say, dear students, we need to find the value of a and b. Now, according to the question, what is the equation of the ellipse? The equation of the ellipse is, if I write that equation of the ellipse in the standard form, so we'll get x square by 13 square plus y square by 5 square is equal to 1. This is the equation of the ellipse. Now, if you just make an analogy with the standard equation of the ellipse, that is x square by a square plus y square by b square equal to 1, what we get, dear students? We get a is equal to 13 and we get b is equal to 5, correct? Now, dear students, what is the eccentricity of this ellipse? We know the formula E is equal to square root of 1 minus b square by a square. If you recall, dear students, that when we discussed the theory of ellipse, and I said that these are the formulas you need to remember, because if you do not remember, it will be difficult for you to proceed in the to find the solution to this question. So now, if we simplify it, dear students, so if we apply these values, that is 1 minus what is b square is 25, and divided by a square is 169. Okay, so we get the value of E as 12 by 13. So the value of E, we get 12 by 13 of the ellipse, which is less than 1, perfectly fine. So what is the focus then of this ellipse? So what is the focus? In fact, we should write it is foci because it is plural. That is plus minus, AE0. If you recall, that is plus minus AE, 0. Now we know the value of A, that is 13, and we know the value of E is 12 by 13. So if we multiply, so that will actually become, A into become 12. So it is plus minus 12 comma 0. Now, according to the question, the hyperbola is passing through the point plus minus 12 comma 0. Correct? So let me give the equation of that hyperbola with equation 1. Now, if you look into the question, the first statement in the question, a hyperbola passing through the focus of the ellipse x square by 169 plus y square by 25 is equal to 1. So that means what we can say is that from this equation, that equation 1, let me use a different color. This equation 1, is passing through the point plus minus 12 comma 0. So let me do it here. Let me utilize this space. So it will must satisfy that plus minus 12 comma 0. So what we get here, dear students, that x square is equal to 144. So it implies that 144 divided by a square minus y square is equal to what, dear students? That is 0 divided by b square is equal to 1. And from here what we get, a square is equal to 144, and eventually we get the value of a is equal to plus minus 12. So from here what we get, the value of a is equal to plus minus 12. So one important information, dear students, do not mix with that a and b of the hyperbola with the a and b in the ellipse. So for example, equation of the ellipse is given as x square by 169 plus y square by 25 equal to 1. So which means we found the value of a and b as 13 and 5 respectively. But in case of hyperbola, it is different, and our target is to find the value of a and b. So a is equal to plus minus 12. Now what is the eccentricity of the hyperbola? So if we assume that eccentricity of that hyperbola as e prime, e dash is equal to what? Square root of 1 plus b square by a square. Right, dear students? So we can write b square divided by a square. So that becomes eventually square root of 1 plus b square divided by a square. A square is equal to 144 because a is equal to plus minus 12. So a square is equal to 144. Now, so this is the value of, e prime. According to the question, if you look into the question, that the product of the eccentricities is equal to 1. The product of the eccentricities is equal to 1. All these informations are very, very important. Okay. And as this is the case, what we can get is that e into e prime is equal to 1, according to the question. E into e prime is equal to 1. Now, from here, what we can write is that, what is the value of e? The value of e is nothing but, 12 by 13. So we can write 12 divided by 13 into e prime. E prime is equal to square root of 1 plus b square by 144. That is equal to 1. That is equal to 1. Now, from here what we can get is that square root of 1 plus b square by 144 is equal to 13 by 12. So this implies square root of 1 plus b square by 144 is equal to 13 divided by 12. Okay, so that implies 1 plus b square by 144 is equal to 169 by 144 because we are making a square of both the sides. Okay, so from here what we get, dear students, is that if we make a square of both the sides, 1 plus b square by 144 is equal to 169 divided by 144. So from here, what we get, dear students? From here, what we get is that, b square by 144, b square by 144 is equal to 169 by 144 minus 1. And if you simplify, that you will get, dear students, equal to 25 by 144. 25 by 144. That implies the value of b square we get is the 25. Correct, dear students? So we get the value of b square is equal to 25. And we already found the value of a square is equal to 144. So as we found in this, purple color, the moment we get the value of a is equal to 12, that implies, a square is equal to 144. And this a square and b square, dear students, that is, one is that a square is equal to 144 and b square is equal to 25. These two are for that equation of this hyperbola. Now, if we apply these values, then what is the equation of the hyperbola? That equation of the hyperbola we get as that x square by 144 minus y square by 25 equal to 1. So we get x square by 144 minus y square by 25 equal to 1. And eventually, if we look into the given options, dear students, that out of this, 5 options, we see that option C is the correct one. Correct, dear students? We get that, option C as the correct one. So we get that option C as the correct one. So, dear students, so like this, I will appreciate that you need to solve this kind of problem by logging to the online platform at KonarClasses.com. I just want to quickly show you how you can appear it, though most of you are aware of it. I just want to show you quickly. It is very simple. So let me stop sharing this screen and let me share another screen quickly, and let me show you that how efficiently you can appear this kind of questions quickly. So dear students, I hope all of you are able to view that website KonarClasses.com. Can someone please confirm that you are able to view this website www.KonarClasses.com? Can someone please confirm, dear students?
Yes.
Okay, great, thanks. So you log in. So you log in with your login and password. So I'm logging with a demo login. Okay, and then after successful login, click into the right practice test. And there are a lot of chapters here. Okay, just you need to give hyperbola. So just give hyperbola. So it comes here. Then go with the right practice test, and you will see that question will start coming. And start solving. Solving these questions will ensure you that you have a great confidence in solving relatively complex questions, and also it helps you to prepare for your different engineering entrance examinations. So with this, dear students, I would like to conclude the class for today. In the next class also we'll be solving some more questions from hyperbola. Before that, I will strongly recommend you to make use of this online platform and appear questions as many as possible. Thank you very much. See you in the next class, that is tomorrow.